Welcome to a better driving experience with the new Detroit DT12 automated manual transmission. By following the steps in this video, you'll be ready to maximize your performance, safety, and fuel efficiency when you take to the road. When you get behind the wheel of a truck equipped with the DT12, you may first notice that instead of a gear shifter, there's a selector stalk. You can use this control to request manual shifts, change the driving mode, and set engine brake levels. These features will be explained in more detail shortly. Before starting the truck, place the battery disconnect switch in the on position and the transmission gear selector stalk switch in the neutral position. Allow the gauges to sweep for about 8 seconds before starting. To get into gear, first apply brake pressure, then move the rotating sleeve on the gear selector stalk to D for drive or R for reverse. The DT12 will quickly and automatically detect the gradient you're starting on and select the appropriate starting gear ratio, usually second. In an unloaded or bobtail situation, the transmission may select up to 5th gear to start the vehicle rolling. Creep mode moves the vehicle at low speeds, improving maneuverability for parking, docking, and heavy traffic without having to press the accelerator. To begin using creep mode, release the service brake and briefly depress the accelerator pedal, thereby fully engaging the clutch. The vehicle's urge to move can then be felt. Following this and for the duration of the current driving cycle, creep mode is active. Once the vehicle is stopped via the service brake, the vehicle will begin to creep again without any accelerator pedal input. You can also select a lower gear while in creep mode for sliding trailer tandems or in stop-and-go traffic, and the transmission can be upshifted or downshifted with the shifter stalk. Hill Start Aid is a key safety feature that holds the load on a grade greater than 3% for up to 3 seconds while the driver moves from the service brake to the throttle. Hill Start Aid and creep mode will work together if creep mode is active. When on a grade, Hill Start Aid will hold the vehicle long enough for creep mode to start slowly rolling the vehicle. Dashboard and audible warnings will alert you to clutch abuse, slipping, or starting in an inappropriate gear. The clutch will not engage until foot pedal movement is acknowledged by the engine. Once you're rolling, the transmission detects the vehicle mass and, depending on the road grade, may choose to use the skip shift feature. Skip shifting quickly moves through the lower gears to save fuel and achieve optimal cruising speed. For example, you may start in 2nd gear, skip to 4th, then to 6th, and up to 8th, before shifting through 1 gear at a time to top gear. Every skip shift improves acceleration. This happens smoothly thanks to the communication process between the engine and transmission. The transmission control module calculates the torque windup in the driveline and regulates with engine torque control. This reduces clutch wear and reduces the jerking motion at startup and protects the driveline. Distinct driving modes let you choose the mode that works best for your current driving conditions. There are 3 driving modes: automatic economy, automatic performance, and manual. Automatic economy mode is the default and, along with intelligent gear shifting, is designed to save fuel. In automatic performance mode, gear shifts are designed for higher performance and are made at higher engine speeds. In manual mode, gear shifts are requested manually. The driving mode can be changed using the mode switch located on the end of the shift control. Press the switch quickly to activate the automatic drive mode or change between automatic economy and automatic performance modes. To activate the manual drive mode, press and hold the switch for about 1 second. In any driving mode, gear shifts can be requested manually. The DT12 enables you to manually shift by pulling the stalk towards you to upshift or pushing it away from you to downshift. In manual mode only, a suggested shift is displayed to indicate the most economical gear available. The suggested shift is the number of up or down arrows from the current gear with a maximum of 2 up or down arrows. If you have 2 up arrows on the dash, you can pull the shifter stalk towards you and hold to upshift to the highest gear available. The same method can be used for downshifting in manual mode. The DT12 will not allow you to select a gear that is not available. You will get an audible warning indicating the gear is unavailable when the shift is attempted, and the DT12 will stay in its current gear. When driving on downgrades, the DT12 may enter E-Coast mode. Here, the transmission temporarily disengages the clutch, so the vehicle maintains momentum while the engine efficiently idles. Engine RPMs will drop to 600 and an E will be visible in the gear display window. E-Coast will remain active until the electronics require torque or there is any input from the driver. At that time, the DT12 will safely and seamlessly resume normal operation when required. E-Coast is only available in automatic economy driving mode. Engine braking with the DT12 can be set by rotating the shifter stalk clockwise. The top position is the off or auto position, which will be explained shortly. At the 3 lower positions, the engine brake is on and the intensity, low, medium, or high, increases with each step down. Engine brakes will work like any other compression braking. Once you let off the throttle, engine braking power will activate, if set to low, medium, or high. The second form of engine braking is the cruise control band switch on the dash, labeled CC band. To use this feature, cruise control must be set, and manual engine braking must be in the off or auto position. Intelligent powertrain management is a key function of cruise control that uses terrain maps and GPS to provide predictive acceleration, shifting, E-Coast, and effective torque management. The purpose of intelligent powertrain management is to use the momentum of the vehicle most efficiently by eliminating unnecessary fueling, engine braking, and shifting while minimizing the impact on travel time. This means IPM uses shifts, acceleration, engine braking, and E-Coast to efficiently operate the powertrain. All these may all occur at different points than you would expect, because IPM is constantly looking up to a mile ahead. Here are a few examples of how IPM plans the route ahead and manages the powertrain. When approaching a steep grade, IPM may increase road speed to allow the truck to climb the hill with the least downshifts possible. It will not increase the speed higher than the cruise control or road limit, whichever is greater. On the downhill side, it may coast or E-Coast before the cruise speed is obtained. Before cresting a hill, IPM may engage E-Coast or stop fueling the engine for 2 reasons. 1, it knows it can crest the hill with the truck's momentum, and 2, it plans for downhill acceleration. Another feature towards the bottom of a grade, IPM will delay the engine's brakes from engaging to increase the truck's momentum for the upcoming grade. IPM will also display your current speed and the maximum speed range on the DT12's ICU display. If the road you're driving on is not covered by the IPM map, the cruise speed range will be replaced with the normal cruise control display. When driving in mountainous terrain, you can adjust the cruise control with the plus and minus buttons, which will also affect the cruise control range of IPM. As you know, you will get better fuel economy the more you use cruise control. Detroit encourages you to use cruise control whenever it is safe to do so. An auto neutral feature electronically shifts the transmission into neutral if not done within 5 seconds after the truck parking brake is applied. An audible warning instructs the driver to select neutral. If the driver forgets to put the vehicle in neutral, a second audible warning tells the driver the transmission has selected neutral. To reselect a starting gear, just move the transmission select collar into neutral and then into drive or reverse with the service brake applied. We're confident that the new Detroit DT12 will give you a significant advantage in making your driving experience smoother, safer, and more efficient than ever. Welcome to the Canadian Rocky Mountains of Alberta. In this video, we'll learn several tips for driving the DT12 automated manual transmission in winter conditions. We will also overview how the DT12 operates in various terrains in winter weather and how to get the safest driving experience. The DT12 is designed to automatically shift based on your throttle input, giving you flexibility for fuel economy and performance. The shift stalk will also respond differently based on your inputs. This is important to consider when driving in slippery conditions. And as always, light, gentle input is safer than hard inputs. The launching process should be very similar to operating a manual transmission. Apply minimal throttle to launch and maintain speed, which prevents wheel spin. The Auto Select Start gear may need to be upshifted by pulling on the shift lever before liftoff to minimize wheel spin or power delivered to the axles at part throttle. Using creep mode is a great option in this type of scenario. It will get the vehicle moving with limited torque. The interaxle differential lock should be engaged when encountering snow-covered terrain before wheel spin is experienced, especially before pulling grades. Differential locks should be disengaged when descending a grade. Rocking the vehicle is acceptable to get out of a stuck situation. Pay close attention to any clutch overheating or abuse. Automatic traction control, ATC, can be turned off in this scenario. Certain tactics should be used based on terrain and wintry conditions. Let's look at some safe ways to traverse grades in snow or ice. In flat terrain, creep mode is the best way to get moving, and speed can be controlled with the shift stalk. Once moving, light throttle will engage regular drive mode. Automated mode will select the appropriate gear, but you can still hold gears or request shifts manually using the shift stalk. A partial throttle approach will minimize skip shifting with the DT12. Automatic traction control will apply brakes to slipping wheels, and engine torque will be reduced. When ABS or ATC is active, automated downshifts will not occur. When climbing a grade, apply only enough throttle to maintain a safe speed. If your speed remains consistent, automated shifting will be limited. You can still hold gears or request shifts manually using the shift stalk. If ABS or ATC activates, automated downshifts will not occur. And finally, when descending a grade, using engine brakes is not recommended. DT12 engine brakes can force a downshift depending on the shift stalk position when in automated mode. If engine braking is required in non-optimal road conditions, position 1 should be utilized along with the service brake. Position 2 could request a downshift based upon speed and application of the service brake. Never use position 3, as it will downshift the transmission. Apply light service brake to prevent gaining momentum or entering E-coast. If ABS or ATC activates, automated downshifts will not occur. After an ABS event, there is a time delay before automatic shifts occur. By adhering to the driving tips on the DT12 automated manual transmission, you can have confidence when driving in various terrains and wintry conditions. You'll get the safest driving experience while maintaining the flexibility for fuel economy and performance. In this video, we will learn about driving the DT12 automated manual transmission in situations like steep downgrades that could result in overspeeding the engine. Unlike manual or other automated transmissions, the DT12 is likely to downshift when requesting engine brakes in order to maximize braking performance when driven in automatic mode. Depending on the model year of your vehicle, the transmission can downshift to a maximum engine RPM of between 2100 and 2300 RPM. A downshift can also occur automatically while in cruise control and descending a grade, as the governor attempts to maintain speed. Apply service brakes or upshift to limit or prevent time above 2300 RPMs. Never allow the vehicle to exceed 2500 RPMs, or damage can occur. It is important to note that service brakes are the primary means to slow a vehicle. Engine brakes are secondary. The Detroit heavy-duty engine brakes are designed to retard the vehicle's velocity if the vehicle is driven at a speed appropriate for the grade and load. Unlike a manual transmission, the DT12 should be managed to a specific speed while in automatic mode. Best practice is 5 miles per hour less than the climb speed on the same grade or posted recommended speed, whichever is less. For those with manual control, it is still possible to operate the transmission in the traditional fashion. For example, descend a grade in the same gear or one gear less than the one used to climb it. If the vehicle is descending a grade at a speed that cannot be sufficiently maintained by the engine brakes, the vehicle will start to pick up speed. It is the responsibility of the operator to control momentum by applying service brakes. Unlike other automated transmissions, the DT12 will not automatically upshift to protect the powertrain. An upshift would only increase the rate of acceleration. If frequent use of the service brakes is required to maintain desired vehicle speed, the driver should snub brake to a lower vehicle speed until a downshift occurs. The lower gear will provide better control with the engine brakes. Repeat this process until service brake application is minimized or no longer required. It is recommended to slow the vehicle to a speed that can be controlled primarily by the powertrain. Start the descent at a speed suitable for the grade. As a reference point, a fully loaded 80,000-pound vehicle equipped with a DD15 and DT12 transmission can control vehicle speed automatically up to 35 miles per hour on an 8% grade. Service brake may still be occasionally required. At greater velocity, service brakes will be required to control speed. Never allow the vehicle to carry the engine above 2,500 RPM. Apply service brakes to prevent this warning. The interactive dash will display a yellow pop-up, Reduce Engine Speed, pre-warning message, coupled with audible pulse tones at 2,300 RPM, and a red pop-up, Reduce Engine Speed, warning message, coupled with a continuous audible tone at 2,500 RPM. Virtual Technician will send an email for these warnings. You should become familiar and comfortable with at least one recommended technique for operating a vehicle on a grade with a DT12. Cruise control, descent control, manual jake in automatic mode, and the more traditional method using manual control of gears and engine brake. It is important to remember that the driver is ultimately responsible for the safety of the tractor-trailer, and that proper starting speed when descending a grade is as important as any other factor. Intelligent Powertrain Management, or IPM, is the Detroit DT12 predictive cruise control feature. It uses global positioning and terrain maps to adjust vehicle speed in rolling terrain to improve fuel efficiency with a goal of not affecting overall trip time. Unlike conventional cruise control, which attempts to maintain a consistent set speed, IPM allows the vehicle to increase and decrease speed around the set cruise speed. For example, the vehicle may slow a little as it approaches the top of a grade if it knows it can make up for it on the downgrade. IPM has three primary modes of operation: predictive acceleration, crest coast, and dip coast. The interactive dash display provides information on the amount of speed variation allowed above and below your set cruise speed. If you are operating on a mapped road where IPM can actively manage your speed, you'll see both a positive and negative number to the right of a larger set cruise speed. In this example, the cruise is set at 60 miles per hour, and IPM allows the vehicle to coast up to 5 miles per hour above the set cruise speed, or by 4 miles per hour below the set cruise speed. Note, this is the key-on default setting. If you're operating in an unmapped area, only the overspeed value will be indicated. Coasting is the primary means of allowing a vehicle to increase speed. The vehicle must be traveling at a speed that can be managed solely by the engine brakes for that given load and grade, or vehicle momentum can exceed the overspeed value. Some vehicles allow speed variation adjustments. In this example, IPM has a target not to exceed 68 miles per hour or slow down below 58 miles per hour. When approaching a steep grade in which IPM calculates the speed of the vehicle which cannot be maintained under full throttle, the vehicle may increase speed as it nears the base of the hill. This is predictive acceleration. This is the only time IPM uses throttle as its primary purpose, to help ensure route time is not compromised. While in economy mode, this can be up to 2.5 miles per hour above your set cruise speed. If you have access to performance mode and are actively in that mode, the vehicle may increase up to 3.5 miles per hour. It's important to note that the vehicle will not exceed any programmed road speed limits. In this example, if the road speed limit is set at 60 miles per hour and you currently have the cruise speed set to 60 miles per hour, the vehicle will not increase speed as it approaches the hill. When cresting a hill or grade, the vehicle may slow down as it approaches the crest and then increase again as it rolls down the other side. When approaching the top of the hill, IPM plans the start of the power reduction and the vehicle reaches the peak at a targeted 56 miles per hour or 4 miles per hour slower than the set speed. You may also enter E-Coast before reaching the crest. Once the vehicle starts the downhill side, speed may increase until it reaches 65 miles per hour, at which time engine brakes may engage and there may be a downshift of the transmission. Where possible, the engine will save fuel by allowing the momentum and engine braking to control speed. On steep uphill grades, where vehicle speed cannot be maintained under full throttle, IPM will still try to crest coast. The vehicle speed may fall below the underspeed threshold if it calculates all the speed will be regained on the downhill side. This is the only time the values shown on the interactive dash display do not represent the true underspeed limits of IPM. In either condition, the driver may depress the throttle pedal during the crest event to override the slowdown phase. This is preferable to canceling cruise altogether and resetting it later. Keep in mind, this comes with a fuel efficiency penalty. As a vehicle approaches the bottom of a hill, IPM will allow it to coast above the set cruise speed if it calculates that the speed will be subsequently reduced by wind and rolling resistance or from another uphill section. In this example, the vehicle is rolling down a minor grade at 62 miles per hour with the set cruise at 60 miles per hour. While descending, the speed is allowed to increase up to 65 miles per hour. The vehicle will then be allowed to slow back down on the rollout or next climb. It is the responsibility of the driver to operate the vehicle at a speed appropriate for the conditions regarding the allowable overspeed value when using IPM. In steeper and more mountainous terrain, special consideration is necessary. If the speed of the vehicle exceeds the upper limit on a downgrade, the driver must intervene, especially if an engine overspeed condition might occur, by applying service brakes. It is recommended to reduce speed to one that can be managed solely by the powertrain and then reset cruise control. You can refer to our online DT12 overspeed protection videos for more detail on this topic. If the cruise control is set at 60 miles per hour and you're approaching a grade with a recommended descent speed of 25 miles per hour, you should reduce the speed well in advance, either by decreasing the set cruise speed with the steering wheel controls or slowing down with the service brakes and resetting cruise. IPM does not know to reset your cruise because of the impending grade. It is the responsibility of the driver to set the appropriate speed in advance. In this specific example, it is recommended to set 20 miles per hour, since IPM allows the speed to increase to 25 miles per hour. This is especially true if the vehicle speed could not be maintained on a steep uphill grade, because the vehicle will continue to throttle back to the original set speed even on the downhill side, depending on the grade and conditions. IPM knows if it is more efficient to e-coast or simply coast. Coasting or engine braking requires no fuel, while e-coasting requires a small amount of fuel to keep the engine idling. You can only gain the fuel benefits of IPM if you're actively using cruise control as much as possible and when practical. If the vehicle enters one of the IPM modes of predictive acceleration, crest or dip coast, and the driver intervenes by applying throttle, engine or service brakes, the opportunity for fuel efficiency gain is lost. If your vehicle is equipped with a collision mitigation system and adaptive cruise control, ACC, which will maintain a set following distance behind a forward vehicle, IPM predictive acceleration and dip coasting will not be possible. The driver must provide enough distance to allow IPM to fluctuate vehicle speed without being overridden by adaptive cruise control. Remember that the driver is ultimately responsible for the safety of the tractor-trailer and establishing the proper speed for the conditions and terrain.